In this video I'm looking at the poster, the new poster for Fantastic Beasts and where to find them. So I'm going to clear out some of the prep work I was doing here as far as examining this poster, and honestly I'm not looking at this one nearly as much aesthetically, and I chose it just because you're able to dissect it and see where they fudged a little on things like linear perspective. So I'm going to run you through what I discovered while looking at it. For one thing, it's, as with many of these posters, nothing that you're looking at actually exists in any way. It's all pieced together. The environment is pieced together from a digital copy, and then the figures are placed in as needed, and that's where you start to see the mistake happen, because I was looking at this one and I was trying to figure out why the figure up front didn't seem right to me. Something seemed off. So as I started just sort of examining him against the figures in the background, he just seems quite a bit bigger than he's supposed to be. And this is something that happens. You know, you fudge a little on perspective so that you can get the impact that you want. But I was curious as to how much, so I decided to run a little experiment with linear perspective here. And I'm not really going to get into other things like the fact that there's light coming from multiple directions, even though the sun is placed up here. The fact that it's coming down casting this long shadow, but yet there's still shadow over here in this corner. It doesn't make any sense. That one you could justify a little. Looks like the steps have just been duplicated from side to side, so light is literally coming from both directions at once. So things like that, not going to concern nearly as much about. Rather, I'm going to show you how to sort of measure this guy and see how tall he really would be. So this one's kind of complicated, and this is one reason I think why it appealed to me some, is the fact that we're dealing with some complexity here in terms of this is a higher plane, this is a lower plane, so it becomes tricky to measure him against that. So what I'm going to do first is raise him up some. So I'm going to go down here and place a line at his heel, and that's his positioning. Now another thing I want to do really quickly is determine precisely where the horizon line falls. We need to know where the horizon is before we can really measure much of anything. So I'm going to use the fact that all lines converge, and I'm going to use these little posts here to just run backwards, come to a meeting point, and that's going to be my horizon line, so about right there. And I can always check that against the outer walls, and it does look like it's about right, more or less. So I'm going to get rid of these two shapes, leave myself here with just where my horizon line and then where his feet are as well. So since I know this is the line on which he stands, I need to lift him up some. So I'm going to use the horizon line and the vanishing point, which was pretty much dead center, and I'm going to determine sort of how high these steps are. And I'm going to lift him up as though he's standing on those steps, so I can measure him against a figure that's up on that higher plane, since they very carefully made sure everyone was higher up, which helps with the disorienting effect. It was a clever move, honestly, by the designer. So from this point here, I'll use a little post, go up, and as soon as I strike that higher line that I've made, that tells me that the steps would be at this height. So I can lift him up and over. I didn't get that quite right. I don't think it's fully level. I'm going to lift him up and over and sort of place him on this plane. But rather than actually do that, I just want to measure him, so I'm going to create a rectangle that represents him in height. Maybe a nice green color. Make it a little heavier so I can see it. So this is going to represent him. I'm going to bring it up to his full height, and then lift that up so it sits right here on the line. So this is how tall he would be if he was standing on this higher plane, as these people in the background are. Now I'm going to measure him against, let's say, this gentleman here who's standing on that same plane. Seems to be a normal sized guy. You know, he's about almost exactly the same height as this guy over here. So I'm just going to measure based on him. I'm going to bring down another guy that's going to represent this line that I created between these two. So this is basically the same height as the upper portion of the stairs there. And switch back to my line tool, except I'm doing stupid things because I forgot to click off of it. There we go. Now I'm going to use the vanishing point and run the line through the bottom of that guy's feet, and then I'm also going to run the line over top of his head right there. And then where this line intersects, to make sure I have these at the same distance, do a vertical line up that meets. Now back to the rectangle tool, and I'll do the same treatment essentially that I did with my foremost figure. So he'd be about that height. So now I can take these over and sort of compare them, and you can see there's a significant height difference. So this figure is obviously bigger, but we can actually figure out precisely how tall he would be if this gentleman back here is of average height. So I'm going to duplicate my rectangle and bring it up here. This is my background guy. This is my main character. Pretty different in height. So I'm going to select that uppermost rectangle here, this one, and my properties panel will tell me precisely how tall it is. So 491. I'm going to pull out, I've got a notepad over here on my other screen, so he's 491 pixels tall. We'll say that. Now if we assume that he's average height, about 59, 5'9", sorry. That's about 69 inches. So I'm going to do 491 divided by 69. So a pixel, I'm sorry, an inch is about 7.12 pixels. Now same thing with my other rectangle here. It is a height of 636. 636 divided by that 7.12, and we have 89 inches is the result that it gives me. So this gentleman is 89 inches tall, which, let's see, 89 inches, I'm really bad at math in my head when it comes to feet. So he's just under 7.5 feet. He's about 7 foot 4.5, 7 foot 5, something like that. So if my gentleman here, my blue box, is 5'9", he's going to be about, we'll be generous, say 7 foot 4. So whenever you bring a figure in, he or she can still be compared to the background. And you can determine based on the other figures how tall he literally would be. Now I went with average height. This guy back here could be of a different height altogether, but he would have to be very short indeed. And comparatively against these other people, he's not. He would have to be very short to justify this figure's size in the foreground.